Welcome back. So this is the continued part of the previous video, the last video. So here I will be discussing the direct form 2 realization of IIR filter. So in the direct form 2 realization, what I do is I am decomposing the transfer function h of z into a product of the two transfer functions, which are namely h1 of z and h2 of z. No doubt the overall transfer function of IIR filter h of z only. To have the direct form 2 realization, I am simply decomposing this h of z into a product of h1 of z and h2 of z, and between these two, in the intermediate state, so I have taken the response of the system is phi of n, and this h1 of z consists of the all folds, and it is all fold of h of z, all fold filter of h of z, and this one is all zeros of h of z, means it is all zero filter, right? And again, as we know that the transfer function of IIR filter is given by h of z in terms of numerator and denominator polynomial, right? So this is a purely a zero polynomial, and this one is the all fold filter, right? So if I decompose this h of z, so I can write the same transfer function like this: 1 divided by 1 plus summation k is equal to 1 to n ak z raised to minus k into summation k is equal to 0 to m bk z raised to minus k, right? So that this can be considered as h1 of z. It has only the folds in the denominator, but if you take this one, so this is only the zero terms, that is b0, b1, so on up to, right? So this is my h2 of z, right? So now if I take, let me take h1 of z first, we'll simplify into its time domain, then we'll convert this z domain to a time domain for h2 of z, and then you can combine both and you will get finally direct form 2 realization, right? So I will take h1 of z first. So h1 of z is given by 1 divided by 1 plus summation k is equal to 1 to capital N ak into z raised to minus k, right? So again, what is this h1 of z? So this h1 of z is nothing but this is all fold filter transfer function whose output is what? The intermediate output p of n, and the input is what? X of n. So if the input is x of n and output is v of n, how can we write h1 of z in time z transform? So which is the z transform of output, that is v of z, divided by the z transform of input x of z, which is equal to 1 divided by 1 plus summation k is equal to 1 to capital N ak into z raised to minus k, right? So once you write all the terms in the z domain, what you have to do is just you have to perform the cross multiplication as you have done in the last case. So how to do this one? So here I will do, so phi of z multiplied with 1 is phi of z plus summation k is equal to 1 to n ak z raised to minus k multiplied by what? Phi of z is equal to 1 into x of z is x of z here, x of z. And for this all fold, what is the output? Phi of n is there. So we have to always write the equation for output in terms of the coefficient as well as the input. So what you have to do is here, again you have to take the inverse Z transform. So what is the inverse Z transform? P of n plus summation, I will write as it is, k is equal to 1 to n ak. And what is the inverse Z transform of this one? So it is P of n minus k is equal to x of n. So I want to express the equation in for P of n. So I will keep only V of n in the LHS side and remaining all terms will take into the right side. So what you will get? So here you will get x of n, right? X of n minus summation k is equal to 1 to n ak into P of n minus k, right? So this is the one equation. Hope you understood, right? And then, so this is one equation. So this gives the output input relation for the first alpha of h of z. Similarly, if you take the second transfer function h2 of z, which is equal to, what is the h2 of z? Summation k is equal to 0 to m and bk z raised to minus k, right? So again you take, what is the h2 of z? For this h2 of z, for the second LTI system, what is the output? Y of n, and what is the input? P of n. So h2 of z is nothing but z transform of output divided by z transform of input. The z transform of output y of n is what? Y of z divided by P of z, and that is equal to summation k is equal to 0 to m, and here it is bk into z raised to minus k. Next step, you know, take the cross multiplication. So y of z is equal to summation k is equal to 0 to m bk z raised to minus k into P of z. So what is this? P of, it is P of z. So therefore, take the inverse Z transform, what you will get? Y of n is equal to summation k is equal to 0 to m, sorry, not m, yes, it is m bk, and what is the inverse Z transform of this one? P of n minus k. So now we got another, the relation between y of n and P of n, right? So these two equations are very important in order to get the direct form to realization of IIR filter, right? So I will rewrite both these equations in the next slide, so that in a single slide with the help of these equations we can realize the direct form to equations. So here I have written the same two equation. Phi of n is equal to x of n minus summation k is equal to n ak v of n minus k, and y of n is equal to summation k is equal to 0 to m bk v n minus k, right? So which both these are derived using the transfer function h1 of z and h2 of z, right? Now with the help of this we'll now realize the direct form to realization. So first we'll consider for the alpha of h of z. So I will consider this one, and for this one, what is the input? The input is x of n, so that we have to write at the left side. And what is the output? The output is what? P of n, right? So here I will write x of n. So here I will write x of n, and here I will write what? P of n. So here I will write P of n. Understood? So here there is minus term and here there is plus term, right? So if I substitute k is equal to 1, if I substitute k is equal to 1 here, what I will get? So I will get a1 into P of n minus 1. you forget about x of n, right? So all these values what you will get, you have to add to the x of n, that is the input, using the adder or summer. So if I substitute k is equal to 1, a1 p of n minus 1 you will get. So what is this p of n minus 1? So how to get this p of n minus 1? So you have to, what you have to do is, so you have to take z minus 1. So after taking z minus 1 you will get p of n minus 1, and this p of n minus 1 is scaled by minus a1 because here it is minus, so you will get minus a1, right? And here you have to give summation because here it is plus, right? Understood, no? So why I have taken plus here? Because k is equal to 0, that term is not there, so directly either you can write 1 or you can simply keep as it is. Understood? Next, substitute k is equal to 2, you will get a2 into p of n minus 2. So you have to take another delay here. So here you will get, so this is my p of n minus 1, p of n minus 2, and this p of n minus 2 is scaled by what?